Hello, this is Mrs. Schroeder. Today we're going to talk about Chapter 5, beginning with simple ions. You can read our objectives. We're going to talk about electron configuration and figuring out the atom's valence electrons and how to make ions for that atom. If you remember, chemical reactivity depends on the valence electron configuration. The most stable group from the periodic table are the noble gases, and they have 8 valence electrons. For example, neon is a noble gas. It has a configuration of a 1s2, 2s2, 2p6, leading to 8 valence electrons. When I draw the Lewis dot diagram for it, I'm going to draw all 8 electrons around it. Now, the most any element can have are 8 valence electrons. There's no place to put any more. Other groups are not stable because the s and p orbitals are not completely filled. For example, oxygen has a 1s2, 2s2, 2p4, or 6 valence electrons, leading to an electron dot diagram that still has room for more electrons around it. The octet rule. Octet stands for 8. This means that atoms tend to gain or lose electrons to reach 8 electrons in their outer valence shell. 8 is the magic number in chemistry. This is the stable number, and they want to be stable. Noble gases already have this. That's why they're stable. Stable meaning unreactive. So as a rule, atoms will not gain or lose more than 3. So this is important to know. How many can you gain or lose? 3 electrons. The only exception is some very large atoms like lead and tin, which may lose up to 4 electrons. As a rule of thumb, groups 1 through 13 lose electrons, groups 15 to 17 gain electrons, and group 14 may either share or lose their electrons. We'll talk more about the sharing part in Chapter 6 with covalent bonding. So if we have to look at orbital diagrams, going back to Chapter 3, nitrogen we said has overall 7 electrons. So when I fill in the orbital diagram and I add my 7 electrons, it's going to look something like this. There's 3 electrons in the p orbital, the others are filled. So how many electrons will nitrogen need to gain to have an octet? Remember, octet meaning 8. I'm trying to fill my outer shell. If I add 3 electrons, this is my outer shell. This equals 8 valence electrons. Or doing it another way, there was 1, 2, 3, 4, 5 valence electrons already. I added 1, 2, 3 electrons to it. Potassium is a little different. Potassium starts out on the periodic table with 19 electrons. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So potassium has 19 electrons. This is a 3p, this is the 4s. So will potassium gain electrons? If it does, remember the octet, the outer level right now is the 4s. If it were to gain, it would have to gain 7 of them to go from K with 1 dot to K with 8 dots. And we cannot, potassium's not strong enough, doesn't have enough protons in the center to gain 7 electrons. So this is not correct. It does not gain 7 electrons. Instead, it's going to lose 1 electron. So if it loses 1 electron, the new outer shell is this, the 3s. In this case, it has 8 electrons in the third energy level. So we would say that potassium loses 1 electron. So we have a new term, isoelectronic. Iso meaning same, electronic meaning electron, same electron arrangement. So when an element gains or loses electron, they'll become isoelectronic with a noble gas. Noble gas because it has 8. It won't just gain to go to 7 electrons, it'll gain enough to go to 8. If I look back and say what element is nitrogen isoelectronic with, so I want to go back to my previous page. Nitrogen, when I gained my 3 electrons, 8 valence electrons, 10 electrons overall, which means 10 protons, which means this is the same as neon. So nitrogen is isoelectronic with neon after it gains 3. Potassium has lost an electron, so this is now gone. I now have filled through the 3p level. This means I have 18 electrons total, which means 18 protons, which is the same thing as argon. So potassium is isoelectronic with argon. And practice, see if you can come up with elements that are isoelectronic with these different noble gases. We'll talk about this in class tomorrow and see how good you did. If this chart is showing you, if you can see this chart, if not, it's in your book. It's the isoelectronic configuration. And what you will notice about this is lithium is shown with a plus charge. Beryllium shown with a 2 plus charge. Nitrogen is shown with a -3 charge. Everything on this chart has charges, plus or minus, after them. When I've gained or lost electrons, I end up with a charge. The neon doesn't. Your noble gases don't have charges because they haven't gained or lost electrons. So overall, when I'm looking at an atom, up until now we've said atoms are neutral, and that is true. It is neutral when it's an atom. Once it's gained or lost an electron, though, we give it a different name. Now we call it an ion. It's a different name. And ions do have charges. They have positive charges or negative charges. 2 terms you're going to have a hard time remembering, cations and anions. Cations are positive. So how to remember it's a positive charge? Well, positive is a plus sign. If I put another plus there, and I draw some ears. So hopefully this looks kind of like a cat to you, okay? With the positive ions in the center. So one way to remember cations are positive. They're positive because they have lost an electron. When you lose an electron, you have more protons than electrons. More protons, more positive charge. Anions are negative. An meaning anti, and somebody who's anti-revolutionary, anti-something is negative. So they are negative ions. In order to become negative, you have to gain a negative charge. Electrons are negative charges. So anions have gained electrons, cations have lost electrons. In order to determine the charge on the following elements, we have to first look at the element, fluorine. We want to know how many valence electrons it has. So you look at your periodic table, count across, and you find that it has 7 valence electrons. If I want to get to 8, I'm going to have to gain 1 electron, which means now I'm going to have 9 protons total, and I'm going to have 10 electrons total. From this you can see the overall charge is a -1 as the overall charge on fluorine. So I would write that as F minus. Sulfur, in the same manner, I look at how many valence electrons it has. Sulfur has 6 valence electrons. In order to form 8, I have to gain 2 electrons. So my overall charge is now 2 more electrons than protons. Sulfur started out with 16 protons. It now has 18 electrons. So overall it has a -2 charge. And I write that as S2 minus. Calcium has 2 valence electrons. Now we said if you have 2, in order to get to 8, I can either gain 6 or I can lose 2 and drop to a lower energy level. Again, it's not going to gain 6, it's going to lose. So this one is going to lose 2 electrons. Calcium started with 20 protons. It started with 20 electrons, but it lost 2 of them to go to 18 electrons, which means I have a +2 charge. So I write this as Ca2+. So these other 3 we'll try in class. I want to see how well you do. Aluminum, phosphorus, and cesium. See if you can do those on your own now. We'll check them in class. Transition metals are a different beast entirely. And I'll show you more in class with how these electrons work, but because they have this D block, which is really close in energy level to the S block below it. Sometimes electrons shift from the D to the S or the S to the D, which gives them different charges. So they could lose 1, 2, 3, or even 4 electrons depending on how those electrons move. This chart on page 163 of your book does show you. Now, it doesn't say titanium, for example, has a +1, +2, +3, and +4 charge. Titanium exists with 2 charges, either +2 or +3. But it could exist in either state. Copper, a common one we use in lab, could be copper +1 or copper +2. You can look at your book and get an understanding. Maybe even mark this page in your books. It's going to be important for you to be able to find this and understand what kind of charges they can have. And we'll go over this tomorrow with explaining why. But ions and their parent atoms have different properties, and they also have different properties than atoms that they are isoelectronic with. Once they have a charge, they become very reactive. And that's what allows our reactions to happen. Those charges, plus and minus, attract each other and get into ionic compounds, which is the next section we're going to get into. So for now, we're going to stop here. We're going to discuss in class tomorrow how transition elements work and also how to do naming of these ions. So make sure you write down your notes and practice those charges of the earlier ones I assigned. We'll see you in class tomorrow.